Okay, welcome back. So now that you have imported your data and then you have cleaned the data, we are now ready to use the data. If you don't know how to import the data, I recommend that you watch the previous video before you come to watch this video, okay, on lecture 2. Yeah, so what I want you to do is go and then copy the second part of lecture 2, R code practice, which is available for you on Canvas. Copy the entire second part. And again, you don't have to necessarily do that. You can copy one code after the other, and then you practice along to better understand, okay? But for the purpose of this lecture, let's copy the entire code, and then let me maximize R and let me put it in here, okay? Let me put it in a different R script, which is here, okay? So I open a different script and put it in here, okay? Now, let me just name this one. What we are coming to do is we are coming to do univariate visualization. So, okay. So that's what we are coming to do now. Okay. 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 All right. So there are two ways to actually do this. Okay. Now it's either after you have imported your iris data set, for instance, and then you have cleaned the data set using the na.omit from the previous lecture. Now you exported the data, okay? So it's either you continue to work with the clean data set straight away, or now you have, assuming you've exported the data, okay, so you now have the data in your folder, which is the clean iris data. So rather than continuing to work with this data here, which is the same as the clean iris data you have in your folder, you decided to rather come back to perform the analysis on the clean data by importing that clean data into R, okay? So let us import that data into R. So let's look for the working directory again. So we have this as the working directory. Let me paste it again, change. You have to change all the backward slash to forward slash. Okay, so now our working directory is set, okay? So let's run it. So there's our working directory. Now our working directory is ready. So now we are going to name the data we are coming to import from the working directory, which is the iris, the cleaned iris data. We are naming it as cleaned underscore iris underscore data, okay? And we are going to use read.csv function to actually read that data set. And then now we say that header is true, which means the data has column headings, okay? Okay, so let's call it. So once we run it, we can see it in the environment, and we have 117 observation and then 5 variables, which means 5 columns, okay? Now, what we can actually do is also use, now, what you should know is that, for instance, if we find a quick summary of our data set, so let's say summary of clean iris data. Let's look at the summary. Now, usually once you start typing the data, it will pop up, so you just have to hit enter to have it inside. Okay, so we have this, the summary of the data. There is no missing value. But look at the species. Now, R is seeing the species as a what? It's a class character variable. So probably this species is what? It's a categorical variable, but as it stands, R have not been able to see this variable as a categorical variable. So we have to now tell R this variable is a categorical variable, okay? So in order to do that, what we are actually going to do is just one line of code in which you just have to write. So we say clean, and then we can bring the $sign. We want the species, so the species, and then, so what we are going to tell R is now go into the data set, and then within the data set, ensure that you make the species a categorical variable. So again, let's call the species. Okay, so now we use the factor function to make it our understand that it's a categorical variable. So now let's rerun our summary. Okay. Okay, so now you can see that straight away we have the species and we're able to read it. We have the setosa, the vesicola, and then we have the virginica. Okay. Okay, all right, so we can go ahead and see the structure of the data set. So R is able to tell the structure of the data set where all the other variables except species is a factor, the rest are numerical variables, okay? And then we have the number of observation, and it's a data frame, okay? So next, let's assume you would want to find a simple scatter plot for the separ length, okay? So again, the way in which you do that is you use the plot function, okay? You use the plot function, so you say plot in our data set, the separ length. So you use the $sign tree to call the separ length from the data set. Now, once you plot the separ length, you give the name of the plot as what? Scatter plot, okay? So we can just select a scatter plot of separ length, okay? And then now what R is going to do is R is going to use the data and the index of the data to draw a scatter plot, okay? Now remember, there is a univariate analysis, so only one variable. Univariate plot deals with you plotting only one variable, okay? So let's run this line of code. Okay, so you have it. So now we have the separ length with its index, okay? And I'll use it to plot a scatter plot of the separ length. Okay, so what about histogram? Now we can choose to plot histogram of the separ length, and the function of the histogram hist. So hist of the data with $sign separ length. Again, we are calling the separ length, okay? And then the main of the data, the main of the plot is the title of the plot, okay? So let's just name it histogram of separ length, okay? Make sure always whenever you plot to give it an appropriate name, okay? So we have it, histogram of a separ length. So now R uses, so we have the y-axis as the frequency, and then the x-axis as the what? As the count in terms of for the histogram, okay? So we have the frequency of the histogram, and then we have the individual bars, okay? So how many individuals count do we have for each of the frequencies? Okay, all right. So, and then which means it also tells us that the separ length actually ranges from 4 to what? From 4 to, I think, somewhere 8. Yeah. Okay. So now we can also have a box plot. Okay. So again, a box plot of the separ length. Okay. Again, now there are several ways in which you can actually go about this. It's either you use the $sign to call the variable from the data, and then use that variable for whatever analysis you would want to perform or whatever visualization you want to perform. Or you can use what is called attach, okay? You can use the attach function to attach the data. Now, once you use the attach function to attach the data, now what then it means is that now R is able to recognize all the variables within the data. So now you can call the variable without first of all calling the data using the $sign. Now, if you want to avoid using the dollar sign. So for instance, over here, we can just say that instead of the data dollar sign, the variable, we can just say, okay, go ahead and plot the separ length, okay, and name it a box plot. So you use main equal with the quotation box plot of, let's say, separ length. Okay, now let's, okay, so there you have, okay. So you know, just like the histogram gives us the distribution of our separ length, okay? And it tells us whether the distribution is skewed or it's not skewed, okay? We can say that it's a little bit skewed to the right, okay? Now, similarly, we can use this button to go back and forth on the plots we've made, okay? So we have the box plot. Again, the box plot is also telling us the distribution, okay, based on the 5-number summary, okay? All right, so now we can also have a dot plot, okay? Yeah, dot plot is also used to visualize continuous variable, and the separ length is a continuous variable. So again, we can decide to delete this part of the code, and just because we have attached the data, we don't have to repeatedly type the data with a dollar sign to call the variable. Now, R know the variables within the data, so R is able to straight away use the variable in the data without using the dollar sign to call it. Okay, so here's a dot plot. Okay, now and then you can actually give it appropriate name, so you can say a dot plot, and if you want to close a particular plot, you can just use this sign and then it close the plot. Okay, so let's assume you want a dot plot of, again, separ length. Okay, now I'll give us actually the dot plot. Okay, yeah. So the dot plot, again, it's actually allow us to be able to even know the frequencies for the various values we have in the data set. Okay. Okay. All right. So now we can also create what is called a pie chart. Okay. Now a pie chart is also used for univariate visualization, and a pie chart is used, you use a pie chart for a qualitative variable, okay, or in other words, nominal variable. So for a numerical or continuous variable, you use dot plot, box plot, histogram, and even how do you call this, scatter plot to better understand that variable, right? But then for a categorical or qualitative variable or nominal variable, you use pie chart. So in our data set, we know the only categorical variable we have here is what? Species. Okay, species is a categorical variable. So how do we visualize species? Okay, so in order to visualize species, we can just use a function called pi. Okay, so first of all, before we visualize the species, we have to tell R, okay, we have to create a table for the species. Okay, and remember, before you can actually perform a pie chart, you need a table of values of the percentages of each of the categorical variable alongside with sometimes the angle of sector, right? Okay, so what we are going to do is we are going to create a new variable. And we did that new variable, we are going to tell R that, okay, takes the species data, okay, and then call it pi species, okay? So that's the new variable we've actually created. In some cases, there may not be even need for us to create that new variable. Once we have attached species, we could have straight away go ahead and use species, okay? But then let's assume we've created a new variable called, we want to name that variable because we are using for a pie chart, we say pi species, okay? So we go to our data set, take the species, and so let's run it and see, let's run that line. And then let's see pi species. So this pi species, which is only giving us what? The all the species we have. And of course, you can actually decide to use the summary of that and see. So pi underscore species. And then it gives you the different categories and then the numbers, the frequencies of that category or the counts. Now we are also going to have what is called labels, okay? Because we want we want to label each of them, okay? So we said that we are going to create a vector of labels. We call it labels, and then we use the assignments sign. So we have Setosa, Vericola, and then Virginica, okay? All right, so now that we have the labels, in the pi function, we say pi what? So before before we use the pi function, there's one thing I actually skipped. You let R understand that the species, you want to create a table for the species, okay? So we have pi species underscore table, okay? And then we can have it pi species, okay? So we use what's called a table function, and that actually create a table for the pi species, okay? And then we are giving it a name, which we are calling it what? Pi species. Okay, so let's run this line of the code. Now we can actually decide to print out the pi species and then see. So this is a table we actually have, okay, for the pi species. Now that it is a table, we can now go ahead and plot our pie chart by using the pi function, the pi species table variable. And then now we have the labels. We remember we create a vector of labels, okay? So we want the labels to come, okay? And then we want the main in our pi function. So this is how it looks like. So in our pi function, the main is representing the title again. So the title is, we are looking at the iris data species pie chart, okay? Yeah. Or we can just say the species pie chart, whichever way, but then just for a demonstration. And then we want a color for the pie chart, okay? Now, for the color of the pie chart, we want to take the length of the table, okay, of the pi species table, which means R is actually going to understand that the number is we are going to take rainbow colors. And the rainbow colors, the number of colors we want for the pi species is what? 3 colors, which is representing the length of the pi species table, okay? We can actually bring this down, okay? So again, let's run the entire code. Okay, so I think something went wrong here. Let us look at what went wrong here. So see object closer. Let's look at it. Okay. Let's rerun it. So something may be wrong here. Let us figure it out. Okay, so let's rerun these lines again and see what is going on. So first of all, we created our pi species. So let's run that line. So again, we're able to know the summary of the species. That's okay. And then we are now creating a table, which we are calling it pi underscore species underscore table. Okay. Now we have the labels of each of the species. Okay, so we have this label variable, which is a vector we are actually creating. Now we are going to use the pi function. So with the pi function, now we bring the pi table followed by the labels, okay, and then followed by the name of the pie chart, which we are naming it iris data species pie chart. And then we also want a color, okay? The color should be equals, we are going to use rainbow colors, and then how many colors do we want in the rainbow? It should take the length of the pi species table, which is our table. So in other words, we are going to have 3 different colors, okay? So now let us run that one. Okay, so now we have it. I'm not sure what was actually happening previously. Okay, so with this given to us, now we can actually include percentages to our pie chart, okay? So in order to include the percentages to our pie chart, we actually have to multiply the table. We have to divide each of the values of the table by the total sum of the table, okay? Now the total sum of the table gives us the total observation in the table. So this code, what this code is doing is we are assigning, we find, let's say, the pie chart percentage, so pi percent, and then we say assign pi percent to, therefore we want you to run it to 1 decimal place, but then you multiply 100 by each value in the table being divided by the total table, the total sum, that the sum of the table, which means the total sum within the table, okay? And that is going to give us the percentages. Now, with these percentages, what we are going to say is, okay, so we want you to now, the labels of the, instead of, we want you to have the labels of the pie chart being equals to the percentages, okay? And again, we have the mean, which is the same as the iris pie chart, that's iris species pie chart. And then again, the color is still the rainbow, and then we have the length, which is the length of the table we actually created, okay, from the species. Okay, let's run this part of the code. So now it actually gives us what? Percentage. Now, if you go back originally, you can actually see that we didn't have the percentage, so we don't know what percentage of this sector represent each of the species, okay? But now we added the percentage, and then we are able to run the percentage, we're able to know the percentage of each species. But now, how do we know which color represent which species? Now we're actually going to use what is called the legend, okay? We can use a legend function, and we want the legend function, we want it to be at the top right corner, okay? So, and then we have the vector of the type of species, which is the 3 species, okay? And then this is actually going to be the size of the legend we have. And then now fill the legend with the rainbow of the length of the table. The length of the table, of course, represents what? 3, which means we have 3 species, okay? So the length of the pi species table, and that's what I did. So remember, if you have a legend, of course, you should be able to know, fill the legend, which actually let us know the color in which each of the colors represent for each of the species, okay? Let's run it. Now we have it here. Okay, so which is at the top right corner. Here is the size. If you increase this number to 2, it's actually going to increase this box, okay? All right, so there's what we have. Now, what you can also do is you can also save this particular plot, okay? And the way in which you can save this particular plot is to use the PNG function, okay? Then the file equal. So what is the name of the file? Now you want to name the file name to be iris underscore species pi, okay? So now we can go ahead and then run this. So once we have run this, if we go to the our working directory, the folder in which we set for our working directory, let's go there. Now we are able to see this file, and then we can actually open it. Now I think there's something wrong with the format. Maybe something has corrupted in my system, but eventually this actually would have been saved. But either way, you can actually even use sniping tool to also cut this plot and then put it in your presentation or in your Word document in your PowerPoint. Okay, now also we can have what is called a 3D pie chart, okay? Now in order to have the 3D pie chart, you can actually use a package called the Plotrix. First of all, you have to install the Plotrix and then you have to library the Plotrix. I have already installed Plotrix. So in this case, I just have to load the Plotrix. Now, once I have loaded, I can now also say pi 3D of what? Of this function, of this table, which is the pi species table we actually created, okay? Remember, we created this table by using the table function, right? So the 3D plot of the pi species table, and then we want you to give it labels, which should represent, again, the percentages in which we created right here, which is this percentages, okay, which will multiply 100 by the relativity of each of the species in the table, which means taking each species frequency and dividing by the total sum of the species, okay? Okay, all right. And then now we want you to also have, we want you to also explode, give us an explosion of the pie chart, okay? Of this 3D pie chart, which means we don't want it to be together as it. We want some explosion, which means separated a little bit. And then give it the name pie chart of iris species, okay? So we use main equal in the quotation marks using this, which is the pie chart species. Okay. Now let us run it. Okay. Yeah, so let's wait. I think maybe test takes some time for it to happen. Let's see the legend. Okay, let's rerun this again. And, okay, so there it is. So I think maybe the system is running slow. Okay, now once it is run, so we are able to get, so this is the explode we were actually talking of. Now, when you increase this number, it actually increases the spaces between each of the sector, okay? So now we can actually also add legend. So just as we added the legend here, we can also add the legend, and then let's add legend. So we have the legend also added, that which color, and it gives it a color representation of each species, okay? So now, again, we can also use this function here, which is PNG, to actually save it into on our computer, okay? Or again, you can just use the sniping tool to cut it for a presentation. Now, what about a bar chart? So pie chart is one way to represent a qualitative variable in a univariate way. Another way is to use the bar chart. So again, with bar chart also uses a table, you're creating a table for that particular categorical variable, which we've already done that. So we are still going to use the pi species table, okay? Which was a table we created for the species, okay, using the table function right here, okay. So we can use that same table for our bar chart. So let's go on with the bar chart. So now we have here with the bar chart again, and then we have n.arg, and that actually allow us to have the labels, okay, to give the labels of the bar chart. And then now we have, now remember this labels right here, we have the labels which we actually define the labels up here, which is representing the labels of the species, which was a kind of a vector we actually created to label each of the species. So in the bar plot names, you use the names.arg equal labels to be able to know the labels of each of the bars, okay? So on the bar plot, give us the X variable should represent the species. Sorry, the X-axis should represent the species, the Y-axis should represent the count. We want you to color the bar plot with it blue, okay? And then also give us the name of the bar plot to be Iris species bar charts. And then also we want you to give the border of each of the bars as red, okay? So let us run this entire code. Okay, so now you can see. So now for each of the species, it's given to us in the bar. So this names.add equal label actually allow us to have the names of each of the bars. And then you can see it's being colored blue with the borders what red. And now we have the counts. Okay. So now we can also have what is called the density curve, okay? Now the density curve is actually used in displaying a numerical variable or continuous variable, okay? So before you can have a density curve for a continuous variable, first of all, you have to create the density points for that variable, okay? So we can tell out that, okay, we are representing x dot density, some variable, okay? And we are assigning that variable to the density of this particular variable, which is the petal length, okay? So we said that go into the the Iris clean data, and then select use the $sign to select the sepal length, and then now create a density points for that sepal length. So now once we have this, we can actually, maybe we can run only the density. Now it actually gives us, so if you run the density, it gives us the 5 number summary, it gives us the bandwidth, and then other info, the number of observation. But now we have the density, we can actually plot the density. So in order to plot the density, you actually use the plot function. So plot the density points of the sepal length in which we created, and then give it the name, let's say the density of sepal length. Okay. Now let's run it. So this is the density. Now we can go a step further to make it look quite beautiful, okay? And by using colors in the density. So we said that color equal light blue, and then the border equal what? Green. So again, that one, we can actually use what is called the polygon, okay? The density polygon actually creates the density polygon a plot, okay? So in this case, we can run, we want to have the polygon of the density, give us a color light blue, and then the border of the plot should be what? Black. So let's run. We can highlight on all of them and run it, or we can just put a cursor and run it. So this is what we have. Now again, also let us understand what the distribution looks like, whether it is skewed or not. But this looks pretty kind of normal, or even it's close to maybe kind of uniform distribution. Okay, all right, now you can use the help function to be able to understand every function you are plotting. For instance, if you want to understand what goes into plotting box plot, you can use the help. So you can use help with the quotation marks or inverted commas, you might call it. And then that gives us every information you need to know about the box plot. You can read all about the box plot. Okay, so now moving away from there, you can also use what is called the ggplot2 package, which is a package which is found in tidyverse, which we will be actually looking into using this ggplot in the future, and entirely a total visualization using the ggplot2. But we can have a univariate for this ggplot2, okay? So in order to use the ggplot2 package, you have to first of all install it. Once you install it, you now have to load it or activate it. So I have already installed it, so now I have activated it. Now we are going to use a data, an inbuilt data in R called the empty mass, okay? So using the empty mass, we are actually going to be able to call that data. So let us call that data. So now the empty mass data is now available, which has 32 observations. Look at the environment and then 11 variables, okay? So now we are going to use the ggplot. So first of all, the ggplot, what it does is we are going to use the ggplot. It asks for the data set, and then it asks for what we want to plot, the histogram of MPG, which is the mass per gallon within this empty cars data. We can actually look for the names. So let's say even the summary of the data. Summary of empty cars, okay? Let's look at the summary of the data. So now we have this summary of the data, okay? So we are actually looking at using the MPG, okay? We want to plot the histogram of the MPG. So ggplot function gives us, this one actually is using selecting the variable we actually want to plot, which is the AES, okay? And then we said the variable X is equals to what? MPG. Then plus. Now, from the plus function, we now want to tell our, okay, you use the geom underscore histogram, and that gives us the histogram distribution of the MPG, okay? So plus geo underscore histogram of, so we want you to give us a beam width of what, 2, and then we want you to fill it with a color which is the steel blue, and then also give us a color of what, black, okay? And then we have GNJ plus, we now have to add the GNJ title. GNJ title is, we say, histogram of MPG. Plus we want the X label, okay? The X label is miles per gallon. And then the Y label, we said, is what? The count, okay? So now we can highlight on this and then we can run it, or we can just put the cursor at the top and run. So here's what we have. So you can see it. So you can see within this, we have the count, which was the Y labeled. You have the X labeled, which is representing the mass per gallon. You have the title, which is histogram of the MPG. And then you actually have the histogram itself. And you have the fill, which was the steel blue, and then the black, which is the borders of the histogram, okay? And this histogram, you can say it looks quite right-skewed, right? Okay, so what if we want to actually plot a bar plot, okay? Let's say we want to plot a bar plot for the species, our iris data, the species of our iris data, okay? So in order to plot a bar plot of the species of our iris data, again, we use the ggplot. We call our data set, which is cleaned underscore iris underscore data. What variable do we want to make use of? We want to plot what? The species. Now the species, you have to make sure you introduce X equal factor so that in the ggplot is able to know that we are dealing species as a factor variable or a categorical variable, okay? Now, we use the geom underscore bar to draw the bar chart. We want to fill in the bar chart with this tomato color, and then we want the borders of the bar chart to be black, which is the color equal black. Again, we have plus. So within the geom bar, you can have this information within the geom bar, or you can choose not to have this information and you can still get the bar plot given, as long as you call the data and then you call the variable in which you would want to plot, okay? And again, because it's a bar chart, you will need a categorical variable for a bar chart. And then we can label our X label, we can have our Y label as well, okay? And then we have the GG title, okay? So either for each step of your ggplot, you actually use the plus to add a new function to indicate what you want actually your plot to looks like, okay? All right, so now we can go ahead and then run this. Okay, so here's what we have, okay? Now what is also interesting is we can actually give, let's say we can say that we can assign this entire plot to a variable. Let's say we can give it a variable iris underscore species. So iris species underscore, let's say bar chart, okay? Then we say that, okay, that is being assigned, okay? So what we are doing here is now we are assigning iris species and iris underscore species underscore bar chart. We are assigning it to this entire plot function, the ggplot function of the bar chart, okay, of the iris species. So in this case, if we run it, we are not going to get any output, okay? First of all, we can delete this one and then see. So let us run this whole again. Nothing will display. But for this to display, we can now have to call iris underscore this one, species, and then we run that one, and now we are able to get it. So what then it means, that's one of the unique things about using the ggplot, okay? Now we can also have a line plot, which we have a line plot, which is a univariate line plot of the MPG within the MT-cars data, and it is going to plot it along with its index, okay? So we said that, okay, plot, ggplot of the MT-cars data. What variable do we need? We want you to actually plot, first of all, we want the X to be from 1 to the number of row of the MG, the number of row of the MT cars, okay? And that should represent our X, okay? And then our Y should be equals to the MPG variable, okay? So now, and then again, we are going to use what is called a function called geoline. You use the geoline to draw a line, and then we want you to color the line with what? Red. So it's a color equal quotation red, okay? Or quote, in quote, red. And then also we have the GG title. The GG title is what the title of the plot, so the line plot of MPG. And then again, we have plus the X lab, which will represent the index, okay, of the MPG. And then also we have the Y lab, which is also going to represent the miles per gallon, okay? Now we can run this entire function, and here's what we have. So we are able to draw a line, which is looking pretty, right? And then we can also have kind of a scatter plot, which we will be talking about it in the future. And a scatter plot is usually used in representing a bivariate distribution, right? Or a distribution which have two variables, right? That's a bivariate visualization, okay? Now, to have, and then what we can actually do is that we can have a box plot, okay? So this one has to actually be a box plot. We can have a box plot of the sepal length for each of the species. So what we are going to tell R to do is that, okay, we are going to use the ggplot. So using the ggplot function, we call our data, which is the iris data. Now, we want you to take X equal the number of species. And then now you are going to give us Y distribution, okay, of the sepal length, which is the numerical variable, okay? Remember the species is categorical variable, but then it's going to give us the distribution of the species of the sepal length for each of the species, okay? Now, fill it with the number of species, okay? So fill equal the number of species. So there's what is found in the ggplot function. Now, plus go ahead and give us, so what type of plot do we want to plot? We want to plot a what? A box plot, okay? So we need a box plot of 8, and then we want you to have actually a team with a legend position at the top. Okay, so you use the team, and within the team function, you indicate that you want the legend position to be at the top, okay? So let's run this. Okay, so there's what you have. So you have the legend position at the top. You have the box plot distribution for each of the species, okay? And then remember, the species was the x-axis within this in the ASE function, and then we have the y-axis representing the sepal length, which is actually the numerical variable, which is showing, which allow us to be able to observe the box plot distribution for each of the species. And then finally, we can also have what is called the scatter plot, which we will talk about it in the future, which is used for a bivariate plot, okay? But then we can actually have a scatter plot of, again, the empty cars, okay? So we say ggplot, use our empty car data set, but then in a scatter plot, we want our x variable to be HP, and then our y variable to be what? MPG, okay? Now remember, if we type in the names of the empty cars, you can actually see the names. So these are the names. So we have, so now it says we want our x-axis to be the HP and the y-axis to be the MPG, okay? And then now you use the geo_points to actually indicate that you want R to plot a scatter plot of these two variables, okay? Then name, and then within the scatter plot, the points of the scatter plot, we want you to give it a purple color. Then you use the GG title to actually give us the title of the scatter plot, which is a scatter plot of MPG, and then the horsepower, which is the HP, okay? X-axis is representing the horsepower, which is the HP, and then y-axis is representing the NPG, which represents the miles per gallon, okay? Now we can run this entire, and this one given. So this giving us a scatter plot, and it shows that we have the miles per gallon at the y-axis, the horsepower at the x-axis, the title with a scatter plot of the MPG, and then you have the points, which is colored with what? Purple. And you can see this actually looking more or less like the relationship between these two is kind of a negative relationship, right? Yeah. Okay, so there's it for univariate plot, okay, using both the normal function, which is the plot function in R, and then also using the ggplot function in R, okay? All right, so I'll see you in the next lecture.